I hope to finish like more example. So let me insert another page. I think the best thing to do on this course is a lot of examples. The more examples you see, it strengthens your understanding of the topic. Okay, so this is P06. This one. Now I will not waste time, or I will not show you how to calculate the second moment of area already. Okay. Just now I want to show you how to check. Now I'm not going to do that anymore. Okay, this structure is so interesting. Okay. So this is example number, I could not remember which example we're on now. That was the one before was example number what? Oh, example number 2. Let's go to example number 3 now. Okay. So we are given the beam is made of 4 boards nailed together as shown. If the nail can support, each nail can support a force of 100 pounds, determine their requirement spacing S prime. Okay, so S prime is this distance over here. Okay, S is this distance over here for the horizontal nail. S prime is for the vertical nail. If the beam is subjected to V is equal to 700 pounds. Okay. Right, so we know the resistance force. Okay, we know that, and we are aware that the V has to carry is 700 pounds. Okay. So for this case, as I mentioned, I'm not going to find the centroid. I just will write down that the IZZ or the centroid. Okay, this you have to find in doing the question. You have to find this value, which is 337.43 inches to power 4, and then the centroid is 3.3548 inches from the top. Okay. Now this problem is interesting. Let me tell you why it's interesting. Where failure will occur? Failure will occur at this point out here. Wrong color. Failure will occur at over here. Okay, on the left hand side, on the right hand side, or at the joint over here. That's where failure will occur. So if we were to construct the shear flow, right? If we were to construct the shear flow will look like this, right? It will come here. Right, that's how the shear flow will occur. But if you look at the left small web, and then if you look at the right small web, they are not linked together, right? So that's where now is considered in thin wall analysis. Now it's considered like a what? A white flange. Can you see that? They're not linked together at all, right? It's independent now. Okay, so now when you consider this, right? So you only need to consider the shear flow on the left web is not connected to the right web because the nail will transmit the load. Then some of you will say, Eugene, what are you talking about? You know this example that you show us? Why we consider this area? Yes or no? Because you consider the entire area because the nails are going through the what? The entire horizontal what? Flange. For this case, right, the nail on the left, horizontal left, and the nail on the horizontal right are not linked at all. Right? They're independent. Whereas over here, this problem over here, the left and right nail, they are nailing down on the entire what? Flange. Okay, that is the difference. Okay, so that's where we consider this. You need to know how to do what? Consider failure analysis. Okay, so as I said, this is the only one that if you look at the textbook, is one of the tough questions for this reason. Okay, so once you consider that, right? Again, the difficult part is the first moment of area. Okay, so let's we're going to determine S for the horizontal nail. Okay, so we are going to find Q, small q, which is equal to VQ over I. So we have V, we have I, so Q is equal, so we only need to consider this small, or let me, sorry, we only consider either this, the left small web, or the right small web. So Q, let me write this out, Q for either left small web or, okay, or right small web, either. Okay, so Q, so the width is equal to 1 inch, the depth is 3 inches, the Y bar is 3.3548 minus by 3 divided by 2. Okay, so 3.3548 minus 3 divided by 2 times by 3 times 1 is equal to 5.564. Okay, 5.564 inch. So once you have this, everything is easy. So Q is equal to V, which is 700. Q, which is 5.564, and then divide by I, which is equal to 337.43. So this is equal to 700.564 divided by 337.43 is equal to 11.54 pound per inch, and this is equal to resistance force of nail divided by S. Okay, so this will be equal to the resistance force given to us is 700 divided by S, and this is equal to 11.543. So S is equal to 700 divided by 11.543. Okay, so 700 divided by 11.543 is equal to 60, no, 700. Is it 700? Divide by, wait, yeah, it's 700. Wait, 5.564 divided by 337.43, 11.543. So 700 divided by 11.543, the spacing is 60.6. Go on, I'm getting something is wrong down here. This is not 700, this is 100. No wonder the spacing is so weird. Okay, the resistance of the nail is 100 pounds. Okay, so force resistance is not 700, it's 100, pardon me. Okay, so this is equal to 100 divided by 11.543 is equal to 8.663 inches. Okay. Now, in reality, it's difficult to measure 8.663 inch. You will usually use 8.5 inch. Okay, it's easier to measure 8.5 than 8.663. Okay, so now this is for the horizontal nail. Okay, so next we're going to determine the S prime for the vertical nail. Okay, so I'm going to do for the vertical nail, I need to see geometry. Okay, so for the vertical nail, we have to consider the first moment of area to consider is this entire section, including this, right? Because the members, so why this whole area? Okay, because the members, right, like for the small web, right? Right, so the small web will distribute the shear flow, right? And then the nails will transmit, right, to the flange, right, to the flange. And then the flange will distribute, and then the nail will transmit again. That's why you take the whole area. Okay. So Q is equal to twice of the first moment of area we find is 5.564. So this is for the left and right small web. Okay, then plus by the width is 10, the depth is 1, and then the 3.3548 minus by 1 divided by 2. Okay, so this is the first moment of area. So it's equal to 2 times 5.564, 11.128 plus by 3.3548 minus 0.5 times 10 times 1 is 28.548. So this will be equal to 11.128 plus 28.548 is equal to 39.676. So finally, still the same thing, Q is equal to 700 multiplied by 39.676 divided by the second moment of area. So this is equal to 700 times by 39.676 divided by 337.43 is equal to 82.308 pound per inch, and then Q is equal to 82.308, which is equal to 100 divided by S. So therefore, S is equal to 100 divided by 82.308, which is equal to 1.215 inch. And yeah, it's difficult to measure what 1.215, so you will use S prime is equal to 1.2. Okay, so I'm going to stop here. Okay, I still got another example to show you. Okay, but not to worry, the example is not that difficult. So the last example is this one. So the last example I just briefly say is this is the area that you have to consider, because the member distribute the load, the nail transmit the load. Okay, Okay, thank you for your time, and I'll see you guys on Thursday then. Okay. Now on Thursday, then I'll let you know your marks for your term test. Okay. I'll see you guys then. I'll still be around if you have any question. Thank you.